Hello, this is Team 3088 Grease Lightning's Control Award for South Florida League Championship. Let's start off with the camera code. The camera code uses the vision processor interface with two rectangles, left rectangle and rectangle middle, having predetermined positions and dimensions. A hue saturation and value matrix, HSMV, is employed using the singleton pattern to detect the starting position. The HSMV is processed calculating the average saturation values, and the rectangle with the highest saturation becomes the chosen position. Rectangles are drawn on this camera stream for debugging. We implemented the A-star algorithm for pathfinding, focusing on two key principles, the G value and the H value. The G value is the cost of moving for a node from previous moves, and the H value being the distance from the node to the destination. The F value, which is the sum of the G and H value, determines the node. Our grid is a 13 by 13 coordinate system with lines as nodes due to obstacles between the tiles. We use the function makeNextMove to navigate by selecting the tile with the lowest F value along its neighbors. A while loop executes the makeNextMove until the robot reaches its destination. This is better than Roadrunner because it has optimal pathfinding, it is much more efficient. Here you can see our autonomous working in real time with the A-star algorithm to calculate its path. We can currently score the 2 preloaded pixels, and we are actively working on scoring at least 4 extra pixels during the autonomous period. Now let's talk about PID controllers, driver enhancements, wrappers, and subsystems. Originally for our linear slides, the built-in method of the DC motor set target position was not accurate. It would sometimes be off by several inches, posing a significant issue for us, as our autonomous routine would vary each time due to the yellow preload being at different heights and causing it to bounce around. To address this problem, we developed our own PID controller and created functions to instruct the linear slide. We implemented several quality improvements for our robot drivers. Initially, we streamlined the operations by creating macros that combine multiple functions into one method. For example, our linear slide control driver had buttons A, X, and Y correspond to different linear slide heights, which enhanced speed and efficiency, whilst the B button was to lower the position, open the F-looking shape of the bucket, and rotating it to its intake position. We also made a macro for hanging, where when you press down the start button, the linear slides wouldn't move down and the drivers could finally put down their controllers. To prevent crashes into the backdrop that could lead to pixel descoring, we incorporated a distance sensor. This sensor, coupled with a hyperbolic tangent function, regulated motor power during driving. We also found out that a Gobilda 312 RPM motors are most efficient at a 0.9 power, which is why we cap it off there. Code organization posed a challenge with lengthy files exceeding 700 lines. To enhance readability and management, we introduced wrapper functions and subsystems. For example, when creating a new instance like bucket equals new bucket hardware map, allowed us to easily access methods like bucket.backdrop rotation in autonomous mode, eliminating extensive code duplication.